In today's tutorial video, we shall be solving these questions on vectors. Question number 1, what is the magnitude of the dot product of these two vectors, B and D? And you should find the angle between them. Number 2 says, find the vector cross product of. So we shall be solving these problems before us. So to get started, how do we define magnitude of vectors? Solution. Magnitude of vectors. To find the magnitude of a vector means to find the length of the vector. So if, for instance, I'm to find a vector is given as, let's say, B equals bxi plus byj plus bzk. To find the magnitude of this vector, okay, we take the modulus. So we have square root of bx square plus by square plus bz square. So we shall be employing this relation to find the magnitude of the dot product. So before we do that, let us find the dot product of B and what? D. Dot product is just like multiplication, but it follows a special pattern. How do we find the dot product of vectors? So to find the product of two vectors, let's say you have a vector A given as AXI plus AYJ AZK, and you have another vector BXI plus BYJ plus BZK. To find the dot product, we take it this way. Dot I to I, have AXBX plus AYBY plus AZBZ. Why is this possible? Dot product is multiplication, but in dot product multiplication, you have to take note of these sign conventions. When you dot I to I, dot J to J, okay, dot K to K, it gives you what? 1. But if you are to dot I to J or J to K, okay, you get what? 0. You get what? 0. So this is what we shall be employing to solve this problem. So if we are to check this now, let's see how it goes. So to do this, I'm going to rewrite this. So I have A dot B. We have not started solving this problem. This is just an illustration. So I have AXI plus AYJ plus AZK. Then you have BXI plus BYJ plus BZK. So you have that. You have this, we go into all of this. So if A subscript X is to go into this, we have AX BX I dot what? I. Plus, if AX is to go into this, it will be AX BY I dot what? J. Then, if this is to dot this, we have plus AXI, okay, or I will write it AX times BZ I, okay, dots I dot K. Then, taking AY, I have plus AYJ, okay, so or AY times BX, AY times BX, J dot I plus AY times BY, J dot J plus AY, okay, times BZ, we have J dot K. Then we'll now take AZ, have AZ times BX, have K dot I plus AZ times by, have K dot J plus AZ times BZ, you have K dot K. Then following the conventions we stated before, you see that this is what? 0. This is 0. This is 0. This is 1. This is 0. This is 0. This is 0. And this is 1. So we have that this is A dot B equals AX BX plus AY BY plus AZ BZ from these conventions. So this is what we shall be employing to solve this problem. So to solve this problem, let us write down the parameters. B equals 6i plus j plus 2k, and D equals minus I plus 3j. Okay, we don't have any component in k, write it plus 0k. So how do we find the dot product? We say B dot D. So in this case, I will multiply I to I, j to j, and k to k. So I will write this is 1, have 6 times 1. Okay, this is minus 1, then have I dot I plus this is 1 times 3, j dot j plus 2 times 0, have k dot k. So this will now be minus 6, I dot I is 1 plus 1 times 3 is 3 because j dot j is 1, so and this is 0. So once we do this, we have what? We have minus 3. So the dot product of B and D is what? Minus 3. So the question says, what is the magnitude of the dot product of these two vectors? So we have found the dot product. How do we find the magnitude? To find the magnitude of this dot product, we take the modulus. So, and we just have minus 3. So we have square root of minus 3 squared. This gives us square root of what? 9, and this is 3. So the magnitude of the dot product of these two vectors is what? 3. So the B part of the question says, what is the angle between these two vectors, B and D? To find the angle, we use this relation. For a dot product, A dot B, the following holds. We have A magnitude, B magnitude, cos what? Theta. So to find the angle, we say cos theta equals A dot B upon A magnitude what? B magnitude. Of course, we have found A dot B before, and we need to find A magnitude and B magnitude for this relation. So how do we go about this using this problem we have solved before? So of course, the angle we have that theta equals cos inverse of A dot B upon half A magnitude B magnitude. So in this case now, we have it as theta equals cos inverse of B dot D. We have B magnitude D magnitude. So how do we go about this? So we continue from our previous discussion. So this will be square root of 410. So if we find the cos inverse of this, we'll be having 98.52 degrees. So this is the angle between B and D, and we found it using this relation. That's for dot products, A dot B equals A modulus B modulus cos what? Theta. So we made use of this relationship to evaluate this. So in this case now, we have B dot D, it will be B modulus D modulus cos what? Theta, and we arrive at this. So we have found that B dot D gave us minus 3, B modulus gave us this, D modulus gave us this. So replacing it here, we now have that this holds. So now let us solve problem number 2. Question number 2 says, find the vector cross product of these two vectors. How do we go about it? So for vectors, okay, in IJK units, so this holds, this is IJK. So this relationship holds if we if we cross I, cross J, and cross K, it gives what? 0. But if we cross I in this direction now, I cross J, it gives us what? K. If we cross J and K, J and K, it gives us I, and so on. But if we decide to cross in the reverse order, we have I cross coming this way now, I cross K, it gives us what? Minus J. If we have K cross J, it gives us what? Minus I. So we shall be making use of this to solve this problem. So we can always also do perform vector cross products using the determinant method. So how do we go about this? So we are asked to find the vector cross product of C and D. So let's now write down the C. We have C equals 2I minus J. So we don't have any component in K. D is I plus 2J minus 3K. So we can use the determinant method. We say C times D. In this case, now we have the I, J, K. Then for the first one, this is 2, this is minus 1, and this is 0. This is 1, this is 2, and this is minus 3. So we use this is plus, the sign convention. This is minus, this is plus. So we take this and we find the minor of this. So how do we go about it? So we have that C crossing D equals, we take this I, then we close this, we have minus 1 to 0 minus 3. So this is how to find the determinant. So we have minus, okay, minus J. You close this and close this, you have 2, 1, 0 minus 3. Then you pick K, it's positive. You close this and close this, you have 2, 1, minus 1, 2. So this is the easiest method of finding the cross products. We can as well do it. So we can as well do it using the previous method. So to do this now, what we do, we say this is I. This now will be minus 1 times minus 3 is 3, minus 2 times 0 is 0. Have minus again. J, 2 times minus 3 is minus 6. 1 times 0 is 0, so minus what? 0. Have plus K, 2 times 2 is 4, minus 1 times minus 1 is minus 1. So we have that this is 3I minus J, this is minus 6, okay, plus K, this will be 4 minus minus, so this is 4 plus 1, this is 5. So we now have that this is 3I plus 6J plus 5K. So this now is the vector cross product of C and what? D. So the B part says, what is the angle between the vectors? So we have found the cross products of C and D, and we have this. So how do we find the angle between these two vectors, C and D? So we shall make use of this relation. A cross B equals A modulus B modulus sine theta. So we shall relate it with what we have as the vectors. So C cross D, we have D is so we have found that C cross D is this. So for this to be feasible, we also take the modulus of this. So we are going to take the modulus of this. So this holds for this. Remember when we did for cross product for dot product, we said that A dot B equals A modulus B modulus cos theta. In this case now, we shall take the modulus of this cross product, because if we don't do that, we won't achieve what we want to find. So going further, to take the modulus of this, we have that the modulus of C and D, cross product of C and D, is square root of this is 3 square plus 6 square plus 5 square. So this is 9 plus 36 plus 25, and we have, so we have this is square root of what? 70. So coming here, we have sine inverse. Remember, this is the modulus. Sine inverse of square root of what? 70 upon. Let us find C modulus. So the magnitude of C, we have square root of 2 square plus minus 1 square. So we don't have any components in K, so we have 0 square. So we have, this is 4 plus 1. This gives square root of 5. So similarly for D, we have square root of, this is 1 square plus 2 square plus minus 3 square. So this gives us 1. This is 4. This is 9. So once we do this, we have, square root of 14. 1 plus 9 is 10 plus 4, this is 14. So we can have, for modulus of C, we have root 5 times modulus of D, root 14. So that theta will now be sine inverse of, so this is root 70. We can collapse this to have this as 5 times what? 14. So we have root 70 upon, this is roots 5 times 14 will give us, 5 times 14 will give us 70. So this gives us 70. So we can take one of the roots. We can say theta equals sine inverse of 70 upon 70, and this gives us sine inverse of 1. And sine inverse of 1, so sine inverse of 1 is 90 degrees. So the angle between the two vectors is approximately what? 90 degrees. And the cross product of C and D is what is given as this. So the next question says, show that B equals this, 9i plus j minus 4k, and D equals 3i plus 7j plus 5k are mutually perpendicular. So we want to show that B and D are what? Mutually perpendicular. So we notice that B and D is perpendicular if the angle between them is 90 degrees. So if we say A dot B, okay, equals A, okay, of course, you know, this is modulus of A, this is modulus of B, cos, if we say cos 90 degrees, so we notice that this is what? 0. So actually, to prove this, we take that the dot products of the two vectors, in this case now, C, B, and D, because that's what we are talking about. So we say this is B dot D equals 0. So this is a relation that holds for what? That holds for vectors that are perpendicular. So I can rewrite this to be, I can rewrite this to now be, this is B dot D equals modulus of B, modulus of D, cos 90 degrees, and cos 90 degrees is 0. So B dot D equals 0. So to show that this is perpendicular, we must find that we must show that when we dot B and D, that it should give us what? 0. So let us do it. We know that this is okay. We know that this is B. B is giving us 9i plus j minus 4k, and C D is giving us 3i plus 7j plus 5k. So to dot this now, we have, this is I dot I, of course this is 9 times 3, I dot I, plus this is 1 times 7, 1 times 7 j dot j. This is minus 4 times 5. This will be minus 20 k dot what? K. So 9 times 3 is 27. 9 times 3 is 27. So have 27. I dot I is 1 plus this is 1 times 7. 1 times 7 is 7. So plus 7 j dot j minus this is 20. Okay, k dot k is what? 1. So this is 20. So this is 34 minus 20. This is 14. So you now see that b dot d is not equal to 0. It didn't give us 0. So it means that b and d are not mutually perpendicular. We say that another definition that shows that this is perpendicular is when theta is what? 90 degrees. So when that is when the angle between them is 90 degrees. So we can as well verify this. How do we go about it? So what you do to verify this, just make this subject of the formula. Okay, you have b dot d, b, the modulus, the magnitude of b, magnitude of d. You find then the cos inverse. So if this gives you 90 degrees, it shows that this and this are perpendicular. Or you can follow it using our previous convention that a dot b should give 0 for it to be what? Perpendicular. So b and d are not what? Mutually perpendicular. So question number 4 says, given that a equals this, given that a equals minus I plus 2j minus 2k, and b equals 3I plus 4j minus 2k. Find the magnitude of a. So the magnitude of a is just this, have minus 1 square plus 2 square plus minus 2 square. And we have this is 1 plus 4 plus 4. 4 plus 4 is 8 plus 1, 9. This is square root of 9. This is 3. So to find the magnitude of b, let's say this is I. Magnitude of b similarly will be square root of 3 square plus 4 square plus minus 2 square. So this will give you let's do it. This is 9. 3 square is 9 plus this will give you 16. 4 times 2, 16 plus this will give you 4. So this will be 16 plus 4 is 20. So you have square root of what? 29. And square root of 29 is 5.385. So how do we find the unit vector in the direction of A? So to find the unit vector in the direction of A, we shall be employing this. To find the unit vector in the direction of A, we shall be making use of this. This is the unit vector. We have A upon the magnitude of A, the modulus of A. And we have it as, of course, the A is given as this. We have minus I plus 2j minus 2k. And we have found the modulus of A to be 3. So this is now the unit vector in the direction of A. So we can have it as minus I, okay, upon 3 plus 2j upon 3 minus 2k upon 3. This and this are the same. Or you can have it as minus I plus 2j minus 2k upon 3. So all these are the same. So this is the unit vector in the direction of A. So the next question says this is I. IV says the direction of cosine. So given that the unit vector in the direction of A is this, the direction of cosine of A are just minus 1 upon 3. This is 1 upon 3, comma, this is 2 upon 3, comma, this is minus 2 upon 3. So this is the direction of cosine of what? A. The fifth question says, for what value of A equals this and this, okay, for what value of A are this and this perpendicular? So two vectors are perpendicular if the angle between them is 90 degrees. They are parallel if the angle between them is 0. And they are coplanar if the determinant, okay, when you find the determinant and it gives you 0, we say that they are coplanar. So in this case now, we want to find the value of A if those two vectors are perpendicular. So how do we do that? So we write the vectors A equals 3I plus 2J minus 4K. B, we have 2I plus AJ plus 5K. So for this to be perpendicular, this relation holds, okay? So I have shown how this is possible. So we have that A dot B equals, this is 3 times 2 I dot I plus 2 times A J dot J minus 4 times 5 is minus 20. This is K dot K is we have K dot K, everything should equal 0. So this gives us A dot B. This is 3 times 2 is 6, okay, plus this is 2A minus 20 equals 0. So A dot B should equal 0. So we can now, from this, we can now say 6 plus, remember this is 20, 6 plus 2A minus 20, that is the A dot B, that it should equal what? 20. So we have that this is 2A plus 6 minus 20 equals 0. So 2A, 6 minus 20 is minus 14. This is minus 14. This should equal what? 0. So 2A equals, if this crosses, you have 14. A will be 7. So the value of A for this and this to be perpendicular is 7. Free to drop the answer in the comment section. If you have enjoyed this video, do well to give it a like, subscribe for updates like this. This is Nacerlifa Academy and we are signing out.